There is a silence that follows certain questions inside NASA. Not the silence of ignorance, but the silence of people who know too much. You can hear it when someone asks what truly comes after Artemis II, after the 4 astronauts swing around the far side of the moon, after they return. The engineers pause. The doctors pause. The physicists look down at their hands. And in that pause lies something the public rarely sees. A growing suspicion that humanity is about to walk into a chapter of its own history for which no one has fully prepared it. For more than 50 years, the moon has waited in our sky like an unfinished sentence. Since the last boot print of Apollo 17 pressed into the gray dust in 1972, no human being has traveled farther than a few hundred kilometers above the Earth. The return has always been framed as destiny. A heroic reunion with a world our species briefly touched and then abandoned. A natural continuation of a line that was cut short by politics and exhaustion. But if you listen closely to the scientists now tasked with making that return real, you begin to understand that the moon is no longer what we remember, and we are no longer the explorers we once imagined ourselves to be. If this kind of exploration speaks to you, if you feel drawn to the questions that stand at the edge of what we truly know, leave your like, subscribe to the channel, and let us continue this journey together. Because what follows is not a story about rockets. It is a story about the fragile boundary between the living and the void. Artemis II will carry 4 humans on a trajectory that arcs past the far side of the moon, the most distant crewed voyage in half a century. It is bold. It is historic. And yet, in the minds of those who understand the physics and the biology of what lies beyond, it is only the threshold, a doorway, the easy part. Because everything being planned after Artemis II, the lunar South Pole landings, the gateway station drifting in a halo orbit above the moon, the permanent human outposts, the eventual leap toward Mars, belongs to a category of endeavor that our species has never attempted, and may not, in any strict biological sense, be built to attempt. You are about to learn why the certainty of the old space age has cracked, why the cheerful renderings and polished timelines hide a different conversation happening quietly in the corridors of laboratories, why the next step is not merely farther, it is stranger, harsher, more revealing than anything Apollo ever faced. The moon we are returning to is not the moon we left, and the humans returning are not the humans who left. Something fundamental has shifted, and the silence of the scientists is where that shift begins to speak. Stand for a moment in your own backyard and look up at the moon. It seems close, familiar, almost domestic. The same pale disk your grandparents saw, the same companion that has pulled the oceans back and forth for more than 4 billion years. Now imagine the International Space Station circling above your head. You can sometimes catch it at dusk, a bright moving point of light sliding across the sky. That station orbits roughly 400 kilometers above the Earth, about the distance between New York and Washington. It feels high because you cannot reach it. But on cosmic terms, it is barely a breath above the planet's skin. You are still, essentially, at home. Now push that distance outward, 1,000 times outward. The moon is nearly 400,000 kilometers away. If the Earth were the size of a basketball held in your hands, the moon would be a tennis ball hovering more than 7 meters across the room. And the space between them is not the comfortable emptiness we imagine. It is a corridor of radiation, of magnetic turbulence, of a cold so deep that ordinary metal becomes brittle. A corridor through which no human being has passed since the Nixon administration. This is what Artemis II will cross, and this is only the beginning of the map that is being drawn. When the planners speak of the Lunar Gateway, they are not describing a second international space station. They are describing a small outpost orbiting the moon in what is called a near-rectilinear halo orbit. A strange, elongated path that loops high above the lunar poles and then swings back in close. Imagine a paperclip, bent and twisted, drifting slowly through vacuum. Astronauts living inside this station will find themselves at a distance where the Earth itself shrinks into the size of a marble, held at arm's length. From their window, our entire civilization, every war, every language, every heartbeat, will fit comfortably behind a raised thumb, and then consider the destination waiting below them. The lunar South Pole is not the sunlit gray desert of the Apollo landings. It is a landscape of eternal shadow. Sunlight grazes that ground at angles so shallow that mountains cast shadows hundreds of kilometers long. Inside certain craters, no ray of sun has touched the floor in billions of years. Temperatures there drop below -200 degrees Celsius, colder than the surface of Pluto. It is, in every measurable sense, one of the most hostile terrains our species has ever proposed to walk upon. To feel the scale in human terms, picture this. If Apollo was a swimmer wading into a cold tidal pool, then Artemis and what follows are that same swimmer stepping, alone, into the open ocean at night. The water is deeper. The current is stronger. The shore is farther. And though the stars above are the same, the silence beneath is a silence that remembers no human voice. Look at the Earth from far enough away, and you begin to see something invisible to those who live upon it. A shield. A vast, luminous bubble of magnetism that stretches tens of thousands of kilometers into space, deflecting the relentless storm of charged particles that the sun and the rest of the galaxy hurl at us every second of every day. We call it the magnetosphere, and it is as essential to life as the air in your lungs. Without it, the atmosphere itself would have been stripped away long ago, as it was on Mars. Without it, DNA would fracture, cells would mutate. Nothing complex could stand upright on the land. You have lived your entire life inside this shield. Every one of your ancestors, every creature that ever walked or swam or flew, every cell that ever divided on this planet, did so beneath that invisible canopy. It is the unnoticed architecture of being alive on Earth. In the moment a spacecraft crosses the outer edge of it, somewhere beyond the orbit of the moon, that protection ends abruptly. What lies beyond is not empty. It is a storm. Galactic cosmic rays are particles that have been accelerated across millions of light years by exploding stars, by supernovae, by collisions between galaxies in the distant past. They travel so close to the speed of light that a single one of them carries more energy than any reactor humans have ever built. They pass through metal. They pass through flesh. They pass through the walls of the spacecraft as if those walls were mist. On Earth, you are struck by them every day. But the atmosphere and the magnetosphere absorb nearly all. Outside, in the naked vacuum of deep space, there is no filter. There is only you and the endless flux. Add to this, the sun itself. Every so often, sometimes once a decade, sometimes several times in a single year, the sun flings a storm of high-energy protons outward into space. A single unshielded astronaut caught inside such a storm would receive a lethal dose of radiation in a matter of hours. On the International Space Station, astronauts can retreat behind reinforced walls. On the moon, there is no retreat. There is only the bare surface, or a habitat that has not yet been built. Consider what this means for the planned Gateway Station, for the long stays on the lunar South Pole, for the 6-month transit to Mars. These are not scenic routes. They are paths across a battlefield that has no beginning and no end. The invisible ocean does not sleep. It does not pause. It does not negotiate. And the longer a human being floats within it, the more quietly it rewrites the biology that evolution spent 4 billion years assembling. And here, at last, we begin to see the paradox that quietly haunts the scientists who plan these missions. The enemy they are fighting is not the vacuum. It is not the distance. It is not even the radiation. The enemy is something far older, far deeper, far more intimate. The enemy is the human body itself and the terms on which it was built. Every bone in your skeleton was shaped by gravity. Every red blood cell in your veins is produced under the pressure of a planet pulling constantly downward. Your inner ear, that delicate organ that tells you which way is up, was refined across hundreds of millions of years to function within a single, very specific gravitational field. Your heart, when it contracts, pushes blood against a resistance it expects to find. Your eyes, your spine, your immune system, even the rhythms of your sleep, all of them assume the earth is beneath them. All of them assume the earth is there. In microgravity, that assumption breaks. Bones lose density at a rate of more than 1% per month, as though the skeleton were quietly surrendering. Muscles weaken even with hours of exercise. The fluid in your body, no longer pulled down, shifts upward into the skull, pressing against the back of the eye, reshaping vision in ways that sometimes never fully heal. The brain itself, astronauts have learned, swells subtly against the cranium, and the white matter pathways that carry thought begin to rearrange. After only 6 months aboard the station, crew members return to Earth altered. They feel it in their balance. They feel it in their hands. They feel it in something harder to name. Now extend those 6 months to 2 years. Now remove the magnetosphere. Now add the deep radiation, the isolation, the distance from any rescue. And you begin to understand why certain researchers, when asked about the long missions ahead, answer only with careful words and carefully chosen silences. Because the honest answer is that we do not yet know. We do not know whether a human being can return from Mars with a mind still its own. We do not know whether a child conceived in lunar gravity could ever develop a spine capable of carrying it. We do not know whether the tissues of an explorer exposed for years to galactic cosmic rays will hold together, or quietly unravel from the inside. This is the paradox at the heart of it all. The very thing that makes us capable of dreaming of other worlds, a body evolved for this one, is also the thing that may prevent us from ever truly living upon them. We are not simply going into space, we are carrying Earth into space, inside every cell we possess. And Earth, torn from its home, is a fragile passenger. To understand what truly happens inside a human body in deep space, you have to descend into a world that no eye can see. A world of single cells, of molecules, of the quiet machinery that keeps you alive without your permission. It is there, in that hidden architecture, that the real story of the coming missions is being written. When a galactic cosmic ray, a single iron nucleus for instance, stripped of all its electrons and accelerated to nearly the speed of light, strikes the soft tissue of a human brain, it does not simply deposit a spark of energy and move on. It tears through the tissue like a microscopic bullet, leaving in its wake a narrow track of damage that can extend through thousands of cells at once. Neurons along that path may fracture their connections. DNA strands may snap in places where the body's repair systems cannot easily reach. And because these particles arrive continuously, day and night, for every moment of every mission, the damage accumulates quietly, invisibly, cell by cell. Experiments on laboratory animals exposed to simulated galactic radiation have shown something that unsettles the researchers who conduct them. The animals do not simply grow sick. They grow changed. Their behavior shifts. Their capacity for memory falters. Their ability to adapt to new situations begins to fade. Brain scans reveal a loss of fine structure in the very regions that make mammals flexible and curious. Now imagine that same process unfolding within a human crew, slowly, across the years of a Mars voyage. The astronaut who leaves Earth may not be the astronaut who returns, in a sense far more literal than anyone is comfortable admitting. And radiation is only one thread in the tapestry. The lunar dust itself, which the crews of Apollo brought back with them on their suits, is not ordinary dust. It has never been weathered by wind or water. Its particles are sharp, jagged, glass-like. the shattered remains of micrometeorite impacts over billions of years. When inhaled, it can scar the lungs. When touched, it clings to every surface, electrostatically charged, impossible to fully remove. On the moon's south pole, where the first long missions are planned, that dust will be the constant companion of every airlock, every seal, every breath. And there is the matter of sleep, of eating, of the gut flora, that quiet inner ecosystem of bacteria that quietly regulates half of what you call health. In low gravity, in confined air, in artificial light, those ecosystems drift. They simplify. They begin to lose the diversity that keeps the body resilient. Little by little, the astronaut becomes not only radiated and demineralized, but colonized by a different internal world. A quieter world. A thinner one. And no one yet fully understands what a human becomes when that inner world has been reduced for years. For every one of these threats, engineers have sketched solutions. And for every solution they have sketched, a new difficulty has risen like a shadow behind the first. This is the strange, recursive logic of deep space exploration. Each answer opens a larger question. Each fix exposes a deeper weakness. The more carefully the scientists look, the more they find that the problem is not a single obstacle to be overcome, but a web of interlocking constraints that resists every pull at any single thread. Consider the question of shielding. If radiation is the silent killer, then the obvious response is to put something between the astronaut and the storm. Lead, water, polyethylene. The thicker the wall, the safer the crew. But every kilogram of shielding must be lifted against the pull of Earth's gravity, carried across hundreds of thousands of kilometers, and then held in orbit or landed upon another world. A truly radiation-proof spacecraft would weigh more than any rocket now conceivable could launch. So the engineers compromise. Partial shielding, storm shelters, strategic placement of water tanks and supplies around the crew's sleeping quarters. But partial protection against a constant flux is, in the end, only partial. The rays still arrive. The damage still accumulates. Consider the question of gravity. If microgravity slowly disassembles the body, then why not create artificial gravity? Spin the spacecraft. Let centripetal force mimic weight. The physics is simple. The engineering is not. A station must be large enough to rotate without making its crew dizzy. Its structure must withstand constant rotational stress. The docking ports, the solar panels, the communication antennas, all must turn with it or compensate for it. And to create even partial artificial gravity reliably on a vessel traveling to Mars is a feat that has never been attempted and may not be attempted for decades. Consider the question of psychology. A Mars mission means more than 2 years with the same handful of people inside a hull barely larger than a suburban house. The Earth, once a blue planet filling the porthole, will shrink until it becomes a star, then indistinguishable from any other star. Radio messages will take up to 20 minutes each way. True conversation with home will cease. And what happens to the human mind when it is cut off that thoroughly from the species that formed it, surrounded by the same faces, the same walls, the same silence, for years on end? No simulation, no Antarctic station, no submarine beneath the polar ice has ever truly reproduced it. The data simply does not exist. And so the planners work in a kind of fog. Every solved problem dissolves into 3 unsolved ones. Every corridor of progress opens into a wider chamber full of unlit doors. The farther humanity reaches, the more it discovers how little it ever truly knew about what it would take to leave. Step back now, and let the consequences widen. Beyond the individual astronaut, beyond the mission, beyond the generation currently alive. For if humans truly do establish a permanent presence beyond the Earth, if the gateway holds, if the South Pole settlements take root, if Mars itself eventually hosts a base that does not depend on resupply from home, then we are not simply building outposts. We are beginning something that, within a few centuries, may cease to be entirely human in the way we understand the word. A child conceived and born off-world would grow within a gravity their body was never designed for. Their bones would form differently. Their hearts would develop under different pressures. Their eyes, their spines, their balance, their sleep, all of these would settle into configurations the Earth has never seen. Their immune systems, shaped by environments far simpler than the teeming biosphere of our planet, would become strangers to the microbial world their parents came from. If they ever returned to Earth, they might not survive the first breath of dense air, the first step in full gravity, the first handshake with someone carrying earthly bacteria. They would, in a literal sense, have become another kind of being. Across generations, the drift could deepen, eyes adapted to low light, skeletons reshaped for thin atmospheres, or for no atmosphere at all. Minds shaped from childhood by the endless night beyond a small, thick window. The descendants of our first settlers might one day look back at Earth the way we now look at the sea from a shoreline, as a place of origin, beautiful and unreachable, to which no one can ever fully return. And there is a darker possibility woven through this, that the radiation, the isolation, the sheer hostility of the environments we send our people into may not produce adaptation at all. It may produce fragility, illness, sterility, a slow dying out, generation by generation, until the off-world branch of humanity quietly withers, and the experiment ends not with a new civilization, but with silence where one was attempted. These are not the kinds of consequences that fit into a press release. They unfold on timescales beyond the careers of the people planning the missions. They belong to centuries no engineer alive will see. And yet every decision being made now, every cubic meter of shielding, every selected astronaut, every approved launch date, is a quiet vote cast into that deep future. We are not merely sending crews to the moon and beyond. We are setting in motion the slow divergence of the human species from itself. And the question the scientists never quite ask aloud is whether, in doing so, we are expanding what it means to be human, or beginning, very slowly, to lose it altogether. And so we return, at the end, to that silence inside NASA. The silence of people who know too much. You can hear it differently now. It is not the silence of fear, nor of doubt, nor of regret. It is the silence of those who stand at the edge of an ancient cliff and, for the first time, truly see how far the fall extends. For millions of years, our species has looked up at the sky and felt something stir that could never be explained by biology alone. A longing that served no evolutionary function, a reaching that had no immediate reward. The same longing that drove our ancestors to cross oceans in hollowed logs, to walk into deserts they could not map, to set their children upon boats they would never see again. It was never rational. It was never safe, and yet it is the oldest inheritance we carry. Older than civilization, older than language, older perhaps than the self that feels it. Now that longing has come to meet the physics, and the physics is answering back. The stars are not closer because we have built larger rockets. The void has not grown kinder because we have drawn better blueprints. Out there, the universe remains exactly as it has always been. Vast, patient, indifferent to our ambitions, shaped by forces that will crush or preserve us without knowing the difference. The only thing that has truly changed is that we have begun to understand how small we are, and how much of that smallness we must carry with us whenever we dare to leave. And perhaps this is the deepest lesson the coming century will teach. Not whether we can reach the moon permanently, not whether we can set foot on Mars, but what we discover about ourselves in the attempt. That the Earth is not the cradle from which we escape, but the body we have always been part of. That every step beyond it is not simply a departure, but an act of translation, in which something of us is inevitably lost, and something new, or something fragile, is inevitably made. That to go is to be changed, And to be changed is to answer, in full knowledge, a question our species has asked since the very first night beneath the stars. What are we when the world that made us is no longer beneath our feet? Artemis the key will fly, and the missions beyond it will be planned, rehearsed, launched. Some will succeed. Some will fail. Some will ask questions we do not yet know how to ask. But somewhere in every one of them, in every quiet corridor of every laboratory, in every pause of every scientist, there will be the recognition that we are no longer merely exploring space. We are discovering what it means to be alive at all.